Welcome! Something new arrived from eBay today, and it is this Heathkit microprocessor learning system. And this is a trainer. This is, I think, probably from 1977. See if there's a date. I don't actually see a date on the back of it anywhere, but I know that the manual that came with it does have 1977 printed on the manual. This is the original ET-3400, not the newer ET-3400A. And back when I was a kid, you know, I would have been less than 10 years old at the time this thing was built, maybe. But I would be getting the Heathkit catalogs in the mail, and I'd always looked at these things and wanted one. Because it's just interesting that you can see all of the components laid out right there where you could imagine working on them. And as compared to other computers of the day, you know, things like, I think my first computer was like a color computer, you know, all of the parts are inside of that, and it's more consumer and less hobbyist friendly. This here feels like something a hobbyist or an electronics person would get, because you could wire your circuits to it. I/O lines and data lines and stuff are all broken out. Just always wanted one of these. I could never afford one. I'm assuming they were like $300-400 back then, and I probably had other things to spend my money on. But I'd been watching eBay for one of these for a while. I'd never pulled the trigger on one, and for whatever reason, a couple of weeks ago I just decided, well, that one looks like a good price and has some stuff with it. I'll grab that, and I will finally have one of these, and then I'll make a video and try it out. Now, Heathkit made a few different versions of this. This is the ET-3400. The ET-3400A came later, and I think it added a crystal for the oscillator. Maybe it changed up the CPU a little bit. A few nice changes in that one, but this is the early version here. They also made an ET-3400 that you might see. I think the difference was that the ET-3400 was assembled, whereas this one, you would get it as a box of parts and you would build it yourself. I think that's the difference. I'm not entirely sure. So in this video, not only am I going to play with this thing and try it out a little bit and show some close-up pictures, but I'm also going to build a memory and I/O accessory to go along with it. The memory I/O accessory would allow you to run BASIC on this thing, as well as have a cassette interface. So along with the trainer, it also came with the original Heathkit manual. And this is what really made a Heathkit, was they had these awesome step-by-step manuals with pictures. These would have just been great. This would have been the Cadillac of kit building. Wow, look, someone actually made some handwritten corrections in there. I am missing the big blow-up charts. It would have been really nice to have those. They would have big fold-out giant schematics that you could put on your table. Don't quite have those. And I do have this microprocessor's flip chart that came with it. If you wanted to learn about microprocessors, look at that. It'd tell you all about microprocessors. You'd flip through this and you'd know some things about microprocessors. Okay, here we are taking a closer look. So this is the ET-3400. Now, if you know anything about these, you'll notice this one has been modified a little bit. The two RAM chips are missing, and this header has been soldered in. So the person who did that was me. When I received this, I immediately started working on upgrading it to support the memory I/O module, and that has you solder in this header, do some wiring inside, and then remove the RAM chips, since the RAM will move to an external module. Anyway, that's just a little clarification in case this doesn't look like what you expected. It's because it has already had those steps done. I just couldn't wait and did that immediately before I even got out the camera. New toy, I had to play with it. Anyhow, I did actually video that upgrade process, so in a few minutes I will show the video of what I had to do to this in order to do the upgrade according to the official Heathkit instructions to upgrade the unit. In the meantime, let's just go over what this would look like stock. So if you could imagine that connector going away, and then these two RAM chips would have been plugged in there and there. It did not come with the other two RAM chips populated. I'm guessing that was an additional option where you would have to get that to get your additional 256 bytes of RAM. So what do you got? You've got a MC6800 microprocessor. One of the things that attracted me to this particular trainer on eBay over other ones is that it had this weird microprocessor with a white PC board and the small black chip on it. I hadn't seen many like that. I don't know if that was common back then, if it was just luck of the draw when you bought one of these, which microcontroller or which microprocessor you got, or whether someone actually damaged the microprocessor and swapped it out for this one over its lifetime. So anyway, you've got the CPU there. You've got a ROM chip that holds a monitor program. You have lots of things that are like buffers. So here are some like line transceiver buffer things. Here's a buffer for the keyboard. You've got some lights here. These are just general purpose LEDs with resistor brought out to a breadboard, so you could build something and you could light up lights. Down here you have a bank of switches, much the same purpose. You could hook something up and then flip switches and run something. You've got your address buffers here. You've got various stuff for the control lines in there. What is this? 5 volt ground, plus 12 and minus 12. Not sure what they're using the plus and minus 12 for, but maybe there's something on here that uses it, or maybe it was just for being able to put some components in, like some op amps or something that would use plus and minus 12 volt. These, according to what I've read, are TIL-312 displays. I believe NTE-3052 is a replacement. It seems like a lot of times you'll find them on eBay and a display or two will be missing. There is circuitry stuck up here under this part. For example, I think the clock circuit is up here. I think the drivers for the displays are up in there. Maybe we'll see some of that when I go through the video where I did the upgrade. I wonder if I can just gently push these in well enough to get this thing to turn on. So this unit is a little bit dirty. I don't know if you can see that. I've always heard that one thing you don't do is buy a used aircraft from Florida. Maybe the same is true of vintage computers. You don't buy a used vintage computer from Florida, because whatever is on here, I tried to clean it off with rubbing alcohol, and it still didn't clean off real well. I did find that if I took a pencil eraser and kind of gave it some abrasion, it would come off, but I'm thinking if this was a Florida unit, the air would be salty, maybe some kind of salt residue or corrosion or something has happened. What you're seeing here on the white, this is actually the printed circuit board, so you can kind of see traces and vias and stuff on it. You can't really paint over it, I think it'd be onerous to try to paint over it from it. There is some yellowing here on the breadboard. This should be really a bright white, where it's kind of a brownish yellowish, and then this case I think has faded over time too. It should be much bluer than it actually is. It should be a brighter blue. But anyway, if I've got these plugged in well enough, let's see if we can get the trainer to start up. There we go. So it's in standby mode right now. Now I think in standby it is probably putting power to the RAM chip so that it doesn't lose memory, but it does not have the CPU going. So let's turn it on, and we get CPU up. Now it's a little bit weird, I've noticed with this unit. Sometimes I don't get all the segments in the display. There, I reset it and the segment lit up. So I thought maybe I need to take a look at those drivers that are in there. I'm not sure. But anyway, CPU up is kind of the iconic thing that this thing says when you turn it on. And we can examine memory. So we could examine FC00. That would be the start of the ROM monitor. And then you can go forward, you can kind of flip through and you can see what bytes are in there. Let's examine the RAM. The RAM is down there at 0000. So there's nothing in there, but I could change that byte. I could change it to 56. And now if I examine 000 again, 56 is in there. So it does seem to be working pretty well. Okay, here we have a program that says turn on and off each segment in sequence beginning at the H display, uses monitor subroutines, redis and out CH, 1 decimal point in each display is active. So I will see if I can punch this in using the keyboard. Being a little bit careful here because the binding on this old manual has seen better days. So I think the program is correct. Now let's do 0, 0, 0, 0. And there we can see it's doing the sample program where it is lighting up all of the segments in the display. Does only do it once? I must have another error in here. Okay, let's see if it continues to loop this time. There we go. Now it's continuously looping like we expected it to do. So I do actually have, right here, a Heathkit catalog from the early 80s. This is, is there a date on it? I'm thinking this was like a 1983 catalog. I don't know, I don't see the date in any obvious place, but anyway, it does have the ET-3400 there. Right there, this is the 3400A. But what's interesting is they sold this ETA-3400. That's kind of confusing. You've got the 3400A as the new trainer, and then the ETA-3400 as the accessory. But they sold this accessory called the ETA-3400 that was the memory and I/O accessory. So it included a ROM with BASIC in it. It included a terminal monitor ROM, an RS-232 connector, cassette input and output up to 4K of RAM, and then a connector cable that connected it to this expansion header. And you could buy that, and then let's say you didn't have a computer at the time, which certainly possible. Computers were expensive back then, but you could turn this into something that you could program in BASIC and do some sort of higher level stuff. So I decided I wanted one of those, but those are a little bit more rare on eBay. You might spend $150, $200 for one of these memory I/O accessories, maybe even more, depending, because they are a little bit more scarce. So I thought, let me try to just build one of those. Why not? I ought to be able to build one of those. It's just serial, RAM, ROM, easy stuff. We should be able to figure that out. Okay, here we are looking at the schematic for the ETA-3400 board that I designed. Usually I do these schematics, I print them out and then go under the camera with a pencil. I thought this time I would just screen capture it. So people, let me know, do you like the screen capture format better, or do you like me setting it out on the desk and actually pointing at the piece of paper? It's all laid out here. I will zoom into some parts of it as we go. This is using the popular Eagle schematic program. So right here, this is the connector for the ET-3400, the 40-pin connector that connects to the trainer. So it's got 8 data lines, it's got some address lines, 16 of them. There's some plus and minus 12 volt, we don't need those. There is 5 volt and ground, those are useful. There is a pair of clock signals. It's actually the same signal duplicated on both sides of the connector. And then there are a bunch of control signals. VMA02 seems to be what it does when it needs to access memory. RE is a signal. It's duplicated on both sides of the connector. That's what it sends back to control the direction of the data bus buffers, whether you're writing to the data bus or reading from the data bus. It's all buffered when it goes over the cable to this trainer. So I got a lot of the ideas from this from the schematics for the real Heathkit ETA-3400. But the difference being I used a few more modern components, whereas they had to use I think 8 static RAM chips. I was able to find one more modern one and use a single static RAM. I used a more modern EEPROM, stuff like that. So anyway, looking around here, let's go up here. Let's skip that. Let's go down here. So here we have the 2 memory chips. So I put in a footprint here for an AS6C6264. That's an 8K RAM. You can also use a 62256, which is a 32K RAM. Doesn't matter. It's just a little difference in the pinout. One of them has an additional address line. The other one has this second chip enable. We're only going to use, I think, 8K of it, but a relatively small amount of this RAM chip, so we don't even care about these two upper address lines. RAM chip takes 12 address lines from the computer. It takes the 8 data bits. The RAM chip has an output enable, which is what you use when you read. It has a write enable, which is what you use when you write. And then a RAM chip select, which enables a chip. So to read from it, you put your address on the bus, you drop the chip select, and then you drop the output enable, and then the RAM will put the data on the data bus. Writing is just the same process using the write enable instead of the output enable. Down here we have a 28C64 EEPROM. That's the electronically erasable programmable read-only memory. It's almost the same footprint as the RAM chip. You've got your address bus, your data bus. There's an output enable and a chip select to read from it. This ready line we don't need. There is a write enable, but I just disabled that because I can't foresee any time when you would want to try to program the EEPROM from the trainer. You know, you're going to program that on the computer and leave it fixed just like it was a non-erasable factory ROM. Maybe I'll come to regret that. I don't know. Maybe people would want to actually be able to write it from the trainer. That seems like a stretch. You've also got over here a 6821 PIA, peripheral interface adapter, maybe something like that. If you're familiar with x86, then you're probably familiar with the 8255 chip. This is kind of like the same thing, but it's a Motorola. So it interfaces the microprocessor to up to two 8-bit ports. So PA0 through A7, that's one 8-bit port. B0 through B7 is the other. Then it hooks up to the data bus. It hooks up to a couple address lines to select some registers in it. And it hooks up to some of the CPU control lines. So you'll notice how it works is a little bit different. Rather than the OE and the WE output enable, write enable, it takes a read write, which this pin selects whether it's read or write, and then it takes the should have a chip select here someplace. Yeah, PIOCS. So the chip select together with the read write tells it what to do. So just slightly different protocol in talking to this chip. It's also got a clock line goes into it and a reset line goes into it. I'm not going to get into the specifics of the 6821. You can just pull up the data sheet and learn a little bit about it. So that is the basics for our memory and our I/O. Now, they only used 4 lines in this thing for I/O. There's a transmit and receive for the serial port, and there's a transmit and receive for the cassette. Several other lines, I think 3 of them, the first 2 jumper lines in this block, were for setting the baud rate. So based on which jumpers you install in here, it would tell the trainer what baud rate you wanted to use on your terminal. I ran a couple extra ones out to more jumper pins. I figure, well, why not? Maybe we can find a use for them. What else do we want to look at? Going over here, out of the transmit and receive, I come over here and I go to these headers with optional inverters. Now, I can never wrap my mind over serial I/O, whether I'm dealing with normal logic or inverted logic. Some devices it'll be inverted, and I will build something. I'll say, oh gosh, now I need to hack an inverter into it. So this one, I just hack the inverter in from the start, put the TX pin through the inverter, and then put a jumper on the other side. I can jumper it to either straight through or inverted. In this case, I turned out not to need the inverters. Of course, that would be the way it would be the minute you put them into the circuit to start with. It turns out you don't actually need them. Of course, I could have just spent a little bit longer analyzing it and figured that out before building it, but board space is cheap. I put them in there. You just leave it unpopulated, and you jumper to here and here where it just passes straight through. The transmit comes through, goes to TTL-TX, the receive hooks to TTL-RX. Then we've got another header. You can see I like putting these headers in because it allows me to change things up if I need to. This is just straight pass through. So we take the transmit and we pass it through into the max 202, and the receive also passes through to the max 202. Max 202 is your standard RS-232 level converter. I think it's got charge pumps in it that manage to up convert the 5 volts to whatever you need to do RS-232. We only need two of the directions in it. We need the transmit direction and the receive direction. You can also do two more pins, and often those would be used for handshaking. The ETA-3400 didn't implement any handshaking. Out of that, I go into another header. Now this one's configured so that you can pass it straight through, and it'll hook through as if this was a peripheral. Or if you flip your jumpers vertically on this header block instead of horizontally, then it would configure this as a computer. So RS-232, you're always dealing with which pin is transmit and which pin is receive. Hence the null modem adapter in the days of old. This header block would allow you to turn this connector into a null modem just by moving those headers around. But for the case of this, just leave them straight through, and the RX and TX hook up over here to the 25-pin DB25. I also brought out the CTS and DSR pins to a couple pads in case we ever need to do anything with those handshake lines. Don't know, probably not. Over here we have the cassette interface. So cassette transmit comes from the 6821. This whole circuit here is just right out of the Heath schematic. So it comes out of there, goes through resistor, capacitor. There's a divider here. This allows you to select the peak-to-peak voltage on the output line. I'm assuming one of them is for microphone input, whereas one is for audio input. I haven't even tried out the cassette circuit yet. On the way back in, cassette comes in from the recorder, going through some more voltage divider type stuff, a couple diodes. What are these for? Maybe to chop off the negative going portion of the wave. Decoupling capacitor, perhaps, to decouple the AC from DC, something like that. I'm not really an analog audio signal guy. But then we go into this comparator. And whatever magic this comparator does, it will output digital over here, which is going to tell you whether the audio pulses on the cassette are high or low. And then that will go into the MC6821 back over here on this side of the diagram, and the trainer will be able to read that. So that is your basics for an ETA-3400. Now I had some additional board space left over, and under the philosophy of let no square inch of board go unused, I also went up here and I put a Raspberry Pi header on it. And the Raspberry Pi, I hooked up its serial pins to the TTL transmit and receive. So the Raspberry Pi can be used as a dumb terminal if we wanted to. Rather than having to plug something into the DB25, you could just use an onboard Raspberry Pi. I also hooked up the cassette port over here, and I hooked up the DB25. I have some plans on stuff to do with the Raspberry Pi. There's one last thing to talk about, and that is address decoding. Now these RAM chips need to be at certain addresses in memory. So RAM, for example, goes to hex 0000 up to hex 0FFF. And then the ROMs, strangely enough, they go from hex 1400 to hex 23FF. It's kind of a weird range. And the PIAA is at hex 1000. Heathkit actually used another ROM for that. It would use the address pins as to address the ROM, and then the chip selects would be on the data bits. I ended up using an ATF16V8 programmable logic. Now, if you looked at my Z80 trainer that I built a few years ago, I used them for address decoding on that too. So I was already familiar with programming these things in couple and writing the programmable logic. So it takes these high address lines and it will assert the RAM chip select, the ROM chip select, or the PIO chip select as appropriate. It also does the translation between the VMA02, the read write, and the RE, OE, and WE lines to deal with this memory having different semantics than the memory that was intended. I also hooked up the upper address bits of the RAM just in case we want to try to do some kind of address translation and actually make the remainder of the 32K memory, throw it into the address space someplace so you could actually use it. I wired the clock pin in. I don't know why. You know, the AT16 V8 designed so that you can give it a clock. We don't actually need it, but I figured, you know, why not? Maybe we'll come up with a use for it and let no pin go unused. And then I also hooked up a little jumper to this OE pin. You can use that as another input. One of my ideas was I could hook a toggle switch up to this, and maybe we could make the RAM or maybe we could make the address decoder do some different shift in some different windows of the ROM. So maybe you could use this as a program select and have it put two different programs into memory. I don't know. Better to have the capability. You don't actually need it. This is my ET-3400, and you can see I 3D printed this case. This case is made out of PETG. The fact that it's both blue and black, that's kind of just an accident of what filaments I had on at the time. I was a little bit short on blue, so I printed the faceplate. I actually have a Heathkit embossed in the faceplate. I printed the faceplate in blue and then the sides in black. I've got the two cassette jacks coming out the back here for the cassette. And then I have my little board here where I implemented the ETA-3400 with its serial port. You can see serial port sticking out the back. I made it so it mounts together with magnets, so there's magnets here in the case, and you just kind of plop it in like that. It holds on there pretty sturdily. Fits right underneath. And then you can take your cable and plug it in like so. And then you would have your ET-3400 along with the memory I/O accessory, and you can come along with serial, plug in the back, and get your basic up on a. So let's take a close-up of the board. Here is the connector where you plug in the ET-3400. Just plugs in like so. Here is the AT28C64 EEPROM chip. Here is the RAM chip. In this case, I think it's a variant of a 62256. Here is the 6821 PIAA. Here we have the MAX 202 serial driver. Back here is the DB25. You can see the DB25 sticking out the back there. Here we have the ATF16 V8, the programmable logic chip that is programmed to do the address decoding and such. Empty socket here for that inverter that we turned out not to need, and an unpopulated socket here for the comparator where you would plug in the comparator for the cassette read function. So I don't actually have that comparator on hand, so I'm waiting for it to arrive from DigiKey before I can test out the cassette. Big connector here is for the Pi0W. If you wanted to add the optional Pi0W, you would mount it upside down like so. And then you would have your built-in serial and stuff for the Pi. Okay, before we can use this ET-3400 with the ETA-3400 memory expansion board, we have to make some modifications to it. We have to plumb in this expansion header, and we have to change the clock. So I have printed the instructions for the modification kit. I have obtained the components, a header, 4 megahertz crystal, a diode, a 22 picofarad capacitor, and a 1K resistor. Let's flip it over. It wants us to remove the rubber feet. We'll save that for later. Can we get a good view of all? Yeah, we can get a good view of all that. So this is the underside of the board. This thing probably hasn't been cracked open in 40 years. Lots of nasty rosin stuff around all the soldering work. But other than that, it looks pretty good. We've got a couple old electrolytic capacitors. Next up is remove and save the 8 hex head screws. Wants us to remove C23 and R49. Fortunately, we have a nice modern soldering tool for that. Okay, so we've removed C23 and R49. Install a 1000 ohm black, brown, red resistor. So we can unplug the desoldering iron. Okay, we've got that. Next up, it wanted us to assemble a combination of a 4 megahertz crystal and a 20 picofarad capacitor. I actually have a 22 picofarad I put in there. I hope it's close enough. So I have already soldered those together, and we're going to plop those in where this capacitor used to be. That looks good enough to me. Okay, next step is going to be to install the header. They actually have us install the header into the IDC connector and then push them in together, but I think we can just insert the header. Should be fine. It's got some stuff here that it wants done. One of these is going to go over here to the clock pin. Looks like it should be over here someplace. Get this angled around so it's a little more convenient to work on. So it did want us to scratch off some of the silk screen on these. One of them is going to be over here. Fiberglass scratch pen is kind of nasty, but it works good for this sort of thing. Just because fiberglass shavings are really nasty, and we'll see if we can pick those up with some tape. We do that. That one there. Rid of any fiberglass shavings, and this one here. Okay, it wants us to remove the hardware that's holding this bracket on. So we've got 2 jumpers to install. One here is for the RE signal, the other is for the clock. Let's do this clock one first with this green wire that I have prepared. I think we got him on there good. Now the other wire, it wants to hook up to a diode. And then we got that diode out here someplace. There he is. It's hooked up to the diode, and then the diode will go to the pins. Out like so. Double check before we solder that we're going the right way. We are. And it's going to go to this pair. You know, Heathkit is renowned for their kit building, but this is kind of dumb, I think, the way that they have this going together. Hit it with the heat gun. call it good. Okay, now it is time to do the ribbon cable. The ribbon cable is going to go down here from the expansion connector up here to the data bus. I'm going to keep clicking on here. And it's going to kind of come right down through there into over here. It actually tells us how to do the color codes and everything on here. So we will just be about doing that. And I think we can reinstall this hardware. And get it put back together. Okay, now we can reassemble the case halves and be done with this. There we go, reassembled. Now let's see if it still works. Stand by. Does it boot up? Ah, look at that, CPU up. Examine. FC 80, sounds right. Looks good to me. Connector's good. There's one pin is higher than the rest. That's because I got it a little bit hot and it slipped a little bit. So here we can see the Raspberry Pi mounted with a couple cables for HDMI and USB. I want to stress this is completely optional to plug this Pi in. It's not necessary. You can always hook into the back to the serial connector, but the Pi gives you the option of having a built-in terminal, and then you could just plug in an HDMI monitor and a USB keyboard, and you could interact over serial from the Pi into the ET-3400 and run its tiny basic without having to deploy another terminal alongside of this. You just use any old HDMI monitor. It is really tight, but it does fit. The ET-3400 will fit on there, and it's like a millimeter of clearance left over. Now I did extend the header up about 3.5 millimeters to get the clearance between this HDMI connector and this chip here, the 6821. To do that extension, I used a stacking header, and then I 3D printed a little 3.5 millimeter spacer. You probably can't really tell too well, but you can probably see that this header is a little bit longer, or a little bit taller than normal. The other thing you can do is, if you wanted to remotely talk to this, the Raspberry Pi, this is a 0W, does support Wi-Fi, so you could have this connected to your serial, and then you could SSH into the Raspberry Pi. Okay, let's turn it on now that we have the memory I/O accessory connected. And then here, let me hit the reset, CPU up, we're good. Now to actually enter the terminal monitor inside of the memory I/O board, you do 1400, and it'll blank the display. And over in the terminal window, we should now have the terminal window up. Okay, so here we are in a serial terminal that is connected to the ET-3400. So when it comes up, when you enter the serial monitor, it prints out this monitor prompt. If we hit the R key, that'll dump the registers from the CPU. Let's see what else we can do. I think we can list display memory. So if we do a D, then let's do 1C0, whoops, D1C00. Let's try that again. Maybe it didn't like the lowercase. D1C00.
0.1C0F. There, that dumped out a row of the memory. This happens to be part of the memory where the basic ROM is. So there's all kinds of commands for displaying and altering memory. You could do pretty much what you could do with the console, the keypad, and LED digits. You could do over here on serial. So maybe this would be handier for entering programs and stuff using a nice keyboard rather than that little keypad on the trainer. I think you can also save and load memory from cassette this way. But another thing you can do is you can jump into the basic interpreter. So if you do G1C00, now we're inside of basic, and this colon prompt is basic. So it has this sample program in the manual. I'll type it in: 100 let I equals 0, 200 print Heath tiny basic 300 I equals I plus 1. If I is less than 5, go to 200, 500 end. And then if we run this, it should print that line 5 times. There we go. And I think it does lowercase too, just not for the keywords. It'll do lowercase for the strings. So Scott was here. And now it ought to print both those strings. Let's see if it works. Yep. Here, let's list the program so we can list it. So this is your standard basic interpreter. You could do high-level basic programming in this, at least as high level as basic gets.
Okay, and there you have it. I hope you've enjoyed looking at this ET-3400 trainer, as well as the ETA-3400 that I built to go with it for memory and I/O so we could run BASIC on it. I'm going to have some more fun with this. I will probably shoot another video in the future because I do want to try out the cassette interface. Since this thing is intended to be interfaced with electronics, I do want to actually implement some of the sample exercises for this too. So there are some that will use, for example, an A to D converter, stuff like that. So I want to try doing some of those experiments that were intended to be used with this. And I'll probably shoot a second video with that as well as the cassette port. So expect another video in this series. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.